Next, we're going to look at writing a polynomial function that has some complex zeros to it. So this is going to be very, very similar to what we did in lesson 5.5 with our irrational numbers, but just think about everywhere that we were seeing the square roots, we are now going to be seeing complex numbers, things with an I attached to them. I'm going to go ahead and note all of my roots. I've been given two roots, 2 and a 3 plus I, but remember that rational roots theorem says if we have a 3 plus I, we must also have a 3 minus I, so let's take that into account and write all of our roots. So our roots are 2, 3 plus I, and then I'm going to change colors and write 3 minus I because that's the one that I had to come up with from using my complex conjugates theorem. So I'm going to abbreviate complex conjugates theorem. And if I have 3 roots, 2, 3 plus I, and 3 minus I, then that means that I must have an x to the third power. Remember, the degree has to equal the number of roots or solutions. Let's go ahead and make ourselves a note here, just like we did when we talked about irrational numbers, that roots are the opposite sign of factors. So we've got to always remember to change the sign when we write going from an x equals something to a factor of x plus or minus something. All right, so let's write our factored polynomial keeping that in mind. I'll say f of x is equal to x minus 2, and then I'm going to have x minus 3 plus I, and finally x minus 3 minus I. So this is my step where I'm taking roots and changing to factors. The next thing I want to do is, I don't like having all these double grouping symbols, brackets here with parentheses and all of that. So I'm going to take the negatives and distribute them to everything in the parentheses to get rid of that double grouping symbol that we've got going on. X minus 2, and then x minus 3 minus I when I distribute the negative, and x minus 3 plus I when I distribute the other negative. So this is a simplify step, or you could say distribution if you'd like. All right, I want to go ahead and start multiplying now. I have 3 polynomials that need to be multiplied together. I'm going to go ahead and take care of the 2 ugly ones first. So I'm going to deal with the ones that have 3 terms and the i's, and I want to multiply those together. So I'm going to just bring down the x plus 2 for now, and then I want to multiply x times every single one of these terms. So I'm going to have x squared minus 3x plus ix. And then when I move to the negative 3, I'll have minus 3x plus 9 and minus 3i. And then finally, when I use the negative I and multiply that times each term, I'm going to have a minus ix, a plus 3i, and a minus I squared. But I'm starting to notice that I've got some opposites that will cancel out. I have a plus ix and a minus ix. I have a minus 3i and a plus 3i. So just like we did with our irrational, with our square root factors, we were able to get rid of a bunch of stuff. Everything that had an I in it in this case, except for this pesky I squared. But remember, we know that I is equal to the square root of negative 1. Let's make ourselves a note over here. I equals square root of negative 1. So that means that I squared is equal to negative 1, because remember, if I square something that is a square root, the square and the square root cancel each other out. So you may want to just kind of bubble that off to the side to remind you of that little rule. And so what we're going to do is we're going to take this entire term, which is negative I squared, and simplify it. I have a negative sign built into the polynomial, but then I know that I squared is -1. So I have a -1. That gives me a +1. So let's go ahead and take a look at what we have left. And I have an x squared. I have a -3x and a -3x, -6x. And then I have a 9 as a constant, and then that 1 that I just figured out, so +10. So we just went from 9 terms to 3. Let's go ahead and make a couple of notes about what we did here. We did a multiply step or a distribution, and then we did a simplify step. And so now let's do another multiply, because I have 2 polynomials now. So I'm going to do a multiply again. So I'm going to say that this is equal to, let's see, x times x squared is x to the 3rd, and then continuing, -6x squared plus 10x, moving to the -2, -2x squared plus 12x minus 20. And now I want to do simplifying again, because I see some like terms that I can combine. So this is equal to, and this will be my final one because I'm not going to have anything else to do, x to the 3rd minus 8x squared plus 22x minus 20.